Okay, hello everyone. Welcome to the CI/CD workshop. I'm Julie, and I'll be presenting today. The main goal of this workshop is just to get a taste of the software development and delivery process used in industry. And then this workshop is designed not to be too hard. So as long as you have background about C, and then you experience Git before, like Git push, Git pull, anything like that, and then you are comfortable looking at command lines and shell scripts, you'll be fine. Okay, so that's a very short introduction. And then I think everybody's ready, so let's begin. First question is, what's the point, right? Why are we here to learn this? So this is memes I copied from Reddit that describes the software development and delivery process. So first you push your code with Git. So SEM is Git file, and then you compile your code. So you build your code, and then you release a product. But after that, instead of having a toast with your coworkers to celebrate, you run and you hide, and then you want to see what's going on. You sort of feel like it will be fine, but you're not sure. And at that moment, you might be scared to get any phone calls where your boss told you, like, you have to fix some bugs. You just pushed, and then you have to come back to office, and there are 5 clients waiting for you. So that will be pretty bad. So during the software delivery process, apart from just pushing the code and waiting the bomb to explode, is there anything better we can do? Fortunately, we have that's CI/CD and CI/CD pipelines. So for this workshop, we already covered motivation. And then for the rest of it, we will explain what it is, and then the workflow of the process. And then we'll focus on live code, and then probably we'll focus on testing. And then we'll have a look at what it's like to release a product, but just very briefly. And then I have some interesting security warnings about CI/CD. And then at the end, we'll try with some trendy CI/CD libraries to see what is available right now for us to use on GitHub. Okay, so that's it. And then we'll just jump to the definition. So what is CI/CD? Well, CI stands for continuous integration, and CD stands for continuous delivery. So continuous integration basically just means once you update your code locally, you should also update it on your repo. So you should push your code as fast as you can and merge your code with the current code base. And continuous delivery means, so probably you have your product and you host some server, then server hosts your product. Whenever you make some change to your code, you wanted to deploy that to your server. But the way you do it is not push your code to the repo and you switch to your server. And on your server, you git pull your new change and then compile and then build and then run again. You want everything to be automatic, right? So yeah, that's continuous delivery. And then CI/CD pipeline, it just means it's a series of steps that must be performed in order to deliver a new version of software. So whenever you push, pull, or you commit, there will be some test triggered, or there will be some checking. There will be anything that you think necessary to perform on your code. Okay, and then the keyword is automation. You don't want it to, you want it just to write a test script and you want it to be triggered every time you push. You don't want it to run your code, you run your test every time. And then same with delivery. You don't want to copy your code to your server every time. Everything should be automatic. And then another keyword is version control platforms. Basically, you can do it with CI/CD with all the version control platforms like Bitbucket, GitHub, GitLab, and Bamboo, like that. Okay. So next is workflow, but I guess many of you probably already can have a guess what that would be like. So very straightforward. First, you just push your code with Git, and then tests will be triggered and run. And then code should be merged into the branch. And then further tests is run if you have more tests. And then this part is delivery. So when you merge your main branch to the deploying branch, your code should be copied to your server, and so that your end users can see your product. And then we can also manually trigger test deployment or trigger test deployment on a fixed schedule, like nightly, fortnightly, like that. Okay. I guess that's it. That's enough about theory. A very great programmer whose name I can't remember once said, the sooner you can tell programmers about mistake they make, the better, right? So, okay, cool. Let's just try to set up a pipeline for our code. Okay, so I come up with some scenarios. First one is, I want to know when some buggy code is pushed. Okay, let's try that. Okay, so we're gonna start from scratch. So I'm gonna go to GitHub and then create a repo. CI and CD workshop, and then create it. Okay, and then copy it. Oh, I have a question. Can anybody see my terminal right now? Because I'm sharing with Chrome. Can you see my terminal? Nope. Okay. New share desktop one. Can you see that now? The terminal? Yeah, okay, thank you. So we'll just clone this empty repo to my desktop. Okay, so we have a repository here. So let's just go to this repository. Let's just write a hello world program. Just print hello world. So can anybody see my VS Code? Okay, so let's just write a hello world program. And then, all right, so add that, and then that will be our first file, and then push. So now it works. It just gets pushed to our repo, very normal process. I guess when I say buggy code, I meant maybe I just define buggy with something that won't compile. So for example, somebody might push some code like that to my repository, and then I don't want that. If anybody pushed any code that won't compile, I want to know. Currently, if we do that, we just currently, if we push a buggy code, nothing happens. It's buggy, but we don't know it's buggy. And then you can see that this won't compile. So what we want to do is we wanted to check whether they will compile after they get pushed. Where's my slide? So let's go to the GitHub Action page. So see if there's anything we can use. So let's first just experience the workflow first. So we just follow the procedure. They say from your repository on GitHub, create new file in this folder. So let's just have a look what folders we have at the moment. So we have dot, it means current folder, and dot the parent folder, .git folder, and main.c. We don't have dot GitHub folder, so just to make one, and then easy, go into there, and then create another folder called workflows. Oh, workflows. Okay, and then they say go to this workflows and then just create a file called GitHub Action YAML file. We can do that. And then it seems to be pretty easy. We can just copy it. So we just sort of explore it a little bit. So this is a YAML file. Some of you might just see the first time. It's just a file with some certain syntax. So it reads like this. So there's some label and some content. So for this YAML file, the name is called GitHub Action Demo, and on means whenever you get push, this will be run. And then jobs is the list of jobs you can have for your code. And then name on jobs and run sounds, steps, run name, they are reserved words. But this is just a name. Explore GitHub Action is just name. You can name it AA if you want. So it says this code should be run on the Ubuntu latest. You should be on the Linux. And then there are a few steps. So because it's just exploration, it just print some GitHub event name, the OS, the workspace, and then the repository. What we need to pay attention is check out step. You have to do that every time for your pipeline, because it won't automatically check it out to your current branch. So other parts are just printing. We'll just try a little bit, okay? Let's just try. Just add everything. Okay, and then commit it as first pipeline push. Okay, so then we go back to our code. There's action. Now it's queued. When it's going to be run. In process. So we can click into that. Oh, it passed. So it's success. So set up a job, and then you just run the job was automatically triggered by push event. If you go back to here, you can see, oh, so push is a GitHub event name. So it just prints something. Now we wanted to use this YAML file example and write our own test file. So we just go to that GitHub workflows folder, and let's just create another YAML file. And just copy it, paste. let's change the name. Just make sure my C program compiles. And then we'll also just make the event to be push, and then just try to compile, give it a name. Oh yeah, it has to be linked by hyphen. Try to compile. And then it also runs on Linux. And then I'm just gonna delete all the printing stuff. And then delete this. So first we check out. Next step, I wanted to install GCC and address Sanitizer. Install GCC and then we need to run. I put code here. So this is install GCC and address Sanitizer on Linux. Paste. So this is GCC. This is address Sanitizer. And then next step, we just compile, and then very simple, GCC main.c. Okay. Thanks. All right, save it, and then let's try to push our code. Okay, and commit. Second. Okay, and let's try to push it. Okay, so let's go back to our GitHub. Where's the? Now we have a commit called second pipeline, and first pipeline is GitHub Action demo, and then it also got passed, right? And second, you can see, oh, it didn't pass. So let's have a look. So try to compile, so it doesn't compile. Huh? Oh, sorry, I think sorry, I think I made a mistake. Oh, sorry. Oh, sorry, it doesn't compile because my it doesn't work because my command is wrong. I'm sorry, this should be smaller X. My bad. Let's try again. The typo. Okay. Wait a little bit, it's cute. You can go to my Outlook, because once there is a failed pipeline, I should get notification. So it's quite slow. Okay, so today at 2:22, it says, well, make sure my C program compiles a workflow run, but it failed. All jobs have failed. And then, I can view workflow run. So you get notifications through your email, which is pretty good. Okay, so fixed typo, this GitHub Action demo still run because it's just independent from my code. And then fixed typo, let's have a look. So, okay, yeah, so we successfully installed GCC and address Sanitizer, but it doesn't compile because in the function main, there is no function declared as pprint, or do you mean dprint? So it caught that problem. All right, so we now know our program doesn't run. So let's just try to figure this out. So this doesn't work, and then just now fix it. Fix the Oh. Now let's push it. And then go back to the actions. Yeah, wait a little bit. And I'm probably gonna delete this GitHub Action demo because we don't need it, right? We'll just explore that. All right, so yeah, now you can see after we fix the bug, the pipeline just run without any error. Okay, yeah, have a look, it compile. Yeah, run that and then it's good. Okay, so so far, is there any question? Oh no, there's 7 messages in the chat. Does it have to be YAML files or is specific to GitHub? I think it's you have to use YAML file. Yeah, they support YAML file. Okay, cool. And then I'm sorry I didn't check chat on time. All right, so that's about this part. Let me just go to the GitHub workflow, and then I really want to delete this because we don't really need it. Okay, so back to the slide. Okay, so scenario 2, I wanted to standardize the code style before it can be committed. So what does that mean? So you notice that those buggy code can actually be pushed to REPL, right? But I want to have something stronger. Like if you can't pass this, you can't even push any code to my REPL. So what we need to use is something called hooks. Let's have a look. All right, so Git hooks, like many other version control systems, Git has a way to fire off custom scripts when certain important actions occur. There are 2 groups of these hooks, client-side and server-side. Client-side hooks are triggered by operations such as committing and merging, while server-side hooks run on network operations such as receiving push commits. I never tried server-side, so I think today I just demonstrate client-side. So yeah, it's pretty straightforward. It will be triggered when certain important actions occur. What kind of actions that will be? So there will be pre-commit, prepare commit message. Never try that commit message, but you can read those on this page. So first, let's try to install a hook. Let's just try to follow this instruction. So first, all the hooks are all stored in the hooks subdirectory of Git direction. In most projects, that's .git/hooks. Okay, so first, let's just try to show all the folders in this REPL. So we have .git. So let's just cd .git and then have a look. So we have a folder called hooks. Okay, just go there, have a look. All right, so we have a lot of examples. For example, pre-commit sample. Let's just have a look. Oh, so and then those are just samples, so those won't be run. So have a look. So it's just a script, shell script. It does something, and then when it doesn't pass the task, it just exit 1, indicating something wrong with it. Okay, so we're not gonna really use it. So let's just create a pre-commit file. Okay, to save everybody's time, actually, put the code in my notes. Let me just copy it. So this is a shell script. Copy. Paste. So what I want to do is actually I can show you. So for example, if my teammate just is a coder, just doesn't follow any style, guidance, just like to submit code like this. So what I want to do is I want to run a style software that help me to standardize the style before this person can push the code. So what it should do is, so somebody have this code, and then I want to run, this. Okay. Every time. Huh? Hold on. Does it help me to? Oh, wait. I think I need to copy this line. Sorry. Main.c. Okay, yeah. As you can see, the style looks much better. All right, but I don't want to do it manually every time. I want it to be automatically. Okay, so let's just be naughty and then do this. Do that. And then, oh, I forgot to explain the code here. So it's a shell script, and then if which claim format 11, it just check whether the claim format 11 is installed on your system, because this will be run locally. I remember the pipeline before, it will be run on the GitHub server. This will be run locally. So if it doesn't installed, then we just say please install. Otherwise, we check the results after running this claim format on our code. If it's just all good, then we don't have to do anything. We just let the person push the code. If not, then we just say there are some formatting issues, and we run this claim format 11 on the code, and then we ask them to commit again. All right, so let's try that. Remember, now this is the bad style, like main.c has the bad style. So git status, git at, git commit bad style. Oh, I see the hook was ignored because not exact executable. Sorry. Also, you have to make it executable. So git hooks and then command commit. Okay, and then let's go back. Status. Okay. Sorry. And git commit and then git. Oh, I think I messed up a little bit. Just commit again. All right. Now you see when we commit, and then it just said, well, there seems to be a lot of formatting problem, and then I already fixed it for you. Please add it again. So now we go back to here. It's already fixed. So it's really nice. All right, so let's just add everything again, and then commit style. Okay, so now we go back to our REPL. Go to actions. It will definitely pass, right? Because this program run, and then this will definitely be passed, and then wait a little bit. It should pass. And now you can see there's no like GitHub Action demo because I deleted. All right, so go back to the code. It's good style. Yeah, it's good style. Okay, so far, any question? I'm gonna have a look at the chat. All good? Straightforward? Shouldn't be too bad. When should we use client-side hooks as opposed to GitHub Actions? Oh, so thank you. So we can have a look at it. So they say client-side not triggered by operations such as committing and merging. So my guess is when we try to contribute to some code, so we try to update the code, we'll try to push something, then that's client side. Server side seems to be like when you pull, when you want to use the code, you want to make sure everything's nice. Does that make sense? I'm not really the expert. That's my interpretation. You probably can have a look at this document. I already have link on the slide. Okay, any other questions? It is replit.com as good as GitHub? Okay. I don't know. Let's have a look. So as long as it's a version control platform, it should be fine. What is that? Use our free collaborative in-browser IDE to code in 50 languages. Okay, so if it's an IDE, I don't think so, because it has to be, so the GitHub is like a cloud, right? So we have code locally, and then GitHub had their server. We push the code to their server. So the server store the code for us. So we actually run the server from GitHub. This, is it actually run a server for you? Like, can you push your code to there? I mean, you can check it out, I guess. I'm not so sure. But if it's just IDE, I don't think so. Anything else? I think it doesn't support a version control step. Yeah. Okay, so I guess that's everything. Alrighty. There's some links I forgot to introduce. So about YAML file, I don't really know much about it. I just know how to read it. So there is a guide for beginners. I think it's quite helpful. And also there's checker. So it's like, you know, some pretty JSON. You just copy and paste your YAML file to there, and they will just tell you whether that's a valid YAML file or not. And GitHub Actions and then hooks. Okay. Does anybody want to take a break? I don't have a lot of content left. I guess we'll just go ahead and continue. Okay, so scenario 3, I want to set up some unit tests. So this time I know the code will compile, but I wanted to make sure the code is correct. It's doing what I expect it to do. So there's no new knowledge here. Let's just try to make it work. But I think I should first have some program, right? So I just want to come up the easiest program in the world. Okay, so this I want to write a function called isPrime and tell me whether the integer is prime or not. So there's a definition. So from 2 to x minus 1 if in mod this value, and then if the result is 0, then this is not prime, otherwise it is prime. We can change it to square x, because all your factors will only be range from 2 to square x, but I don't want to include the math library, so I'll just leave it like this. And then I guess I just wanted to I want to read integer, and then okay. All right. So that's definitely correct. And then, yeah, so if I wanted to write test for this program, and I wanted to add in a pipeline, what should I do? Okay, think a little bit about it. Okay, I think everybody probably has an idea. So what we're probably gonna do, just very similar to test YAML file. So after we compile this code, right, we probably want to run some scripts on it, and making sure that the output is same as expected output. So I have some code here. So we want to have a shell script. So basically, I wanted to create a folder called tests, and then have a lot of input in .in file, and then want to run this program, and then check against the output, and then if there's any difference, then the test should fail. Okay. So first I probably want to have a prime like 3. 3 is a prime. To test one .in, then test one .in dot accept. Okay, and then let's put a composite number. Test 2, okay, so we have those files, and then yeah, I think that's finished. Let's just try a little bit. I might write some bugs, and that should be fine. We can fix them later. So let's just add them all together. Oh, I forgot to write the YAML file. So here, after I compile the main.c, I actually wanted to change the name, compile, just call it unit test maybe. Tests name, and just to run test.shell. Okay, should be fine. All right, just make sure. I don't know whether I need to do this. Maybe I don't need to. Okay. Okay, so everything's ready. Edit tasks. Code should be clean form. Oh, okay. So the clean format for me. Thank you. Thank you so much. And then that's for me. Okay, so that's done. Let's go back to our REPL. Okay. That's not. Oh, actions failed. Okay, let me have a look. We're gonna go into the debugging mode. Fail, test one in actual and test one expected differ. Oh, really? Let's have a look. Why I didn't see any actual? Why it doesn't create any? Let me just run it locally to have a look. And then print nothing. Try the new line or something. Why is nothing got printed? Oh, okay. Now try again. Okay, print something. What doesn't work? Have a look. Oh, what? So I should add a new line? Okay. Cool. All right. So yeah, as you can see, sometimes you still have to, test locally. But I guess the benefit of pipeline is once you really set it up, it will be triggered automatically. And then you will know what's going on, like something's wrong and you fix it. Right. Oh, actually, I wanted to delete it. Otherwise, oh, that's actually be fine because they will be overridden. But I still want to delete it. Quite slow. Mm. Okay. Oh, already had it. Comments. Let's see whether this time that will work. Okay, back. It's queued in progress. Okay, that passed, right? So it compiles and then it runs tests. And then the exit status is 0. It means nothing's wrong. Okay, so we finished. I think that's everything about integration. Is there any questions so far? Let's have a look at chat. Nope, all good. All right. Okay. Yeah. All right. Next will be release. So scenario is I want to release a project. I want the GitHub to copy my code to my server. I think we just have a quick look because it highly depends on your languages. I'm writing in C, but let's face it, nobody gonna have a C product in C. C is usually for lower level stuff. So I don't think it's really that necessary to show that. And also it only makes sense if you have a product to deploy. And also you have a server, right? I didn't prepare any server today, but we can have a look what it might looks like. So this is the code. So similarly, we can say, well, name is generated release. And then whenever it's get pushed to the branch release. So you can see now this is branch specific. And then we have a list of jobs. Build and release, it runs on Linux. Steps first, you check out. And then you need to create a release tag with this. And then with environment, I copied this from the document. And then you install the build tools and you build this product. And then in my case, I just create archive for this a.out. And then I just zip it and then release to the GitHub with name like this, and then with some token. So the release process is just depends on what you want to do. And then YAML file still the same, like the process, you can see the workflow is still the same. You have some process and you do something. Okay. All right. I don't think I should take any break because because I think we probably finished soon. So, all right. And then, so after all the live code, we go back to theory part. So there is some security issues about CI/CD. So GitHub recently had a wave of bots using this to mine cryptocurrency using GitHub Actions on other repositories. So that's pretty interesting. Let's have a look at it. Where is it? Oh, it's here. Okay, so GitHub Actions is currently being abused by attackers to mine cryptocurrency on GitHub servers in an automatic attack. So this is happened recently in April. So yeah, so Action is a CI/CD solution that makes it easier to set up periodic tasks for automating your software workflows, but they can be exploited by the attackers. I had a read of this, and then actually I don't really know like who is the victim. Is that GitHub or the people who hosted the code, people who released the code? So they did it by forking other people's repository, and then they insert some actions on the pull request like that. My interpretation is you basically insert your mining code in Action because all the pipeline run on the GitHub servers. So you're actually asking GitHub to mining for you. So you don't have to run it locally, but it doesn't say the details. So I'm not sure. If you're interested, you can have a look about this. So it's pretty cool. Yeah. Okay. Obviously, if you have a private repo, you don't really mind. This is when people want to contribute open source, right? That could happen. All right. That's security warnings. That's surprisingly short. Okay, then this is the last part of our workshop. It's just we're gonna try some popular libraries. I think I'm gonna talk about Superlinder, setup Node.js environment cache, and then I think deploy to GitHub pages is the most practical one. So have a look. Basically, how to visit them. I just want to show you how we can use these libraries. So this is like the top, I don't know, the most popular libraries we can find on GitHub. So this is the most popular one. So maybe we can have a look at it. So there are some descriptions. It says, well, there are some goals. So it can prevent broken code from being uploaded to the default branch. You know, a little bit like what we did previously, right? And then it can help establish coding best practices across multiple languages, assuming they're talking about style, and then, yeah, comments. And then build guidelines for code layout and format. Oh, sorry, this is about format. I'm not sure what that is. Maybe you can have a look in their document. And then automate the process to help streamline code reviews. Yep. And then they have a lot of details on the page. If you decided to use it, very simple. You just go to here and then pick a version. You just use the latest version, and then you just copy that. And then you just, go to here and then just paste it, and it's done. So very straightforward. Honestly, I'm not gonna demo this part because I tried it in week 6. I don't think it really works with C. It probably works with other language. So like after using it, I don't see what's the effect, but you can explore it. But as you can see, it's quite simple, right? They write everything for you. It's just like using a library, you just copy it in your YAML file. As long as you know how to set up the workflow. That's super linter. There's anything else? I think there was one. Oh, and if you're very familiar with Docker, you can use it. I think it could be quite helpful. But Docker is a hot topic, so we'll just skip it. Why I can't click on it? Oh. Okay, so set up Node.js environments. Basically, you just you check out and you say, I'm going to use Node 14, and you just install all the dependencies on the GitHub server, and then you just run a test script. It's quite straightforward. You can actually do it yourself, right? And npm really makes it very easy. So that's also something you can try if you have a Node.js project, backend project. And then, so I have to visit again. The thing I think could be quite useful is deploy to GitHub pages. So, so if you have, I know it's pretty hard to buy a server and then host it and then copy code to there. First, you have to buy a server, right? And then you have to buy some name domain like that. So it can be pretty tricky if you don't know the deployment process. So what I did when I was second year, I wanted to create my personal website. So I just write a pure front-end website, and then I just let GitHub to host it for me. I didn't use this Kint, by the way, but I think it could really make it very easier. So you can have a look at my website. Oh, by the way, if you have backend, if you have a backend in your website, then I'm not sure GitHub can host it very easily. But basically, this is all front-end stuff. I just have one time I was really passionate about the Canvas library in JS, so I tried to draw something. Yeah, so it's all front-end. And yeah, this is my frog piano. Don't know whether you can hear that. So something like that. It's all front end, and then you can just, so if you only know front end, you just create your UI with no problem, and you buy some name domain from GitHub, and then you just use this to help to deploy your code to the GitHub pages, and then you should be fine. Then there's no need to buy any server and no need to host it.